Welcome to the Guide on Database Design Implementation. Today we explore how to turn a conceptual design into a fully functional SQL schema. This video covers the essential steps from attributes to complete create table statements, ensuring a robust and efficient database structure. Our journey begins by converting the conceptual entity relationship diagram into the physical structure of an SQL schema. The first major step is implementing attributes, where we define the building blocks of our tables. Conceptual entities like passenger or booking are converted into distinct database tables, and their descriptive attributes become the columns within those tables. Crucially, each new column must be assigned an appropriate data type, such as INT or varchar, and necessary constraints to maintain data integrity. Next, we address plural attributes, those that can hold multiple values for a single entity, requiring a special approach. Plural attributes, such as multiple phone numbers, are implemented by splitting them into new, separate weak tables. This new weak table includes the plural attribute itself and a foreign key which links back to the original main table, establishing a clear relationship. To ensure the quality and consistency of data, we apply specific column constraints. We use unique for attributes that must be distinct, not null for required fields, and primary key to uniquely identify each record. With attributes and constraints defined, we can proceed to generate the actual SQL code. The resulting script fully specifies the database. For example, the passenger table requires INT primary key for ID, varchar not null for name, and varchar unique for email. These individual create table scripts collectively form the complete database schema, ready for deployment. The final critical step is reviewing the tables for third normal form, or 3NF, a standard for eliminating redundancy. This review process helps us spot and highlight redundant data, which can lead to inconsistencies and wasted storage space. If redundancy is found, tables are decomposed into smaller, related tables to ensure data consistency and fine-tune the overall design. To summarize the whole design process and its benefits, we move from defining attributes and constraints to generating complete create table statements and finally to normalizing the design. This meticulous process guarantees a database design that is efficient, consistent, and reliable, providing a solid foundation for any application. Database design
complete. We have table 5.91 and it shows implement attributes. So we have the steps. We have steps 7A, 7B, 7C, and 7D, and the activities that each step represents. Okay, so for example, step 7A, the activity involved in step 7A is to implement plural attribute as new weak tables. 7B is to specify cascade and restrict rules of new foreign keys in new tables. 7C, you specify column data types corresponding to attribute types. And 7D, you enforce relationship and attribute cardinality with unique and non-null keywords. So we have a participation activity here just to test our comprehension of implementing attributes, and let's go through it. So question 1 says plural attributes are implemented as new weak tables. Alright, plural attributes are implemented as new weak tables, and this is true. Yes, so plural attributes become a new table identified by the table derived from the entity containing a plural attribute. So if maximum cardinality is a small fixed number, the plural attribute can be implemented as several columns in the initial table. However, a separate weak table is usually preferred. Now, let's look at the second statement. The logical design phase ends when attributes have been implemented as columns. Okay, attributes implemented as columns. Specify column data types corresponding to attribute types. Alright, that seems to be true. Let's check. Incorrect. So it's incorrect because following attribute implementation, tables are repeated for third normal form. Tables that violate third normal form may be revised to eliminate redundancy. So the statement was saying logical design phase ends when attributes have been implemented as columns. So that is false. So this statement is false because following attribute implementation, tables are reviewed for third normal form. Tables that violate the third normal form may be revised to eliminate redundant data. So an attribute name indicates the data type of the corresponding column. Let's check. Yeah, this is what we saw. Alright, so it's step 7C, and that is true. Yes, correct. Attribute name contain a standard attribute type. So each attribute type corresponds to a data type documented in glossary. Good. So let's go further into an activity on implementing attributes just to get the understanding. So we have 4 steps here, and the first question is which properties apply each attribute. So you have the attribute of chart code RU, chart size R, and chart size R. So first we'll start by mapping the properties for each attribute in the chart entity. So from the attribute constraint from the diagram, we get that chart code RU is more of chart code RU required plus unique. That is required plus unique. So R is required, RU is unique. So chart size R is required. So chart price R is required. So this should be simple for us because we are given R and U. So R is required. So chart code that is R is required and U is unique. Chart size R is required. Chart price R is required. So that is that. Good. Let's get to the next. So P, following an attribute in case an attribute is plural. So no attributes are plural in this case. R, following an attribute in case an attribute is required. So we have R following our attribute. So in this case, we know that the attribute is required. U, following an attribute indicates an attribute is unique. So when we have U following our attribute, we know that that attribute is unique. So from the table we see, from the original table we saw that state code RU is required plus unique, which is the primary key. State name RU required plus unique. Population count R required. State name P, plural meaning multiple nicknames per state. So when you're handling plural attributes, since state nickname can have multiple values of one state, we create a new table. So state nickname, this links each state code to one or more state nicknames. So we have the attribute of state code, we have the attribute of state name, and we have the attribute of population count and state nickname. So in this case, state code goes to P. So state code goes to primary key, and at the same time it goes to foreign key. State name does not go to either column, primary key, or foreign key. Population count does not go to either any of them. Then state nickname goes to column, primary key. So this goes to column and primary key, and state code also goes to column. So we can check our answer, and yes, that is what we expected. So as you can see this explanation, the table contains plural attributes, that is state nickname, and foreign key state code referencing to the state table. So the primary key is neither state code nor state nickname, is unique in the state nickname table. So however, the composite state code state nickname is unique. So foreign keys is the primary key for the state table, which is state code, right? Okay, let's finish this up. So this will be my chart 2. Okay, then this will be var char 12, and this will be int. So I'll want you to go through, screenshot this and read through. Okay, so we go to the final part. So here we write not null, uh, not null, and this one is not null. All right, we fail. So the first one is primary key, the second one is not null, and the last one is not null. And these are the explanation as to why what happened. Okay, so this is primary key. All right, so we are done. Go through the explanation so that we get the point.